All right, ladies and gentlemen, we're going to be talking about slope-intercept form today. So basically what we're going to be talking about is how do I write a linear equation in this form that's going to tell me certain pieces of information. And actually, the name of it will kind of tell us some of the things that we're going to get out of this. But basically, a linear equation that we write in this form, y equals mx plus b, is in what we call slope-intercept form. And what that means is that m is actually telling us what the slope is, and b is telling us the y-intercept. So I said earlier about how, hey, the name's going to kind of tell us what we get from it. A linear equation in this form will show us what the slope of that line is, and will also show us what the y-intercept of that line is, okay? So we actually can look down here, and if we want to write an equation of a line that has a slope of 2/3 and a y-intercept of 6, we actually can go ahead and write that in y equals mx plus b. So the way we do that is we literally take this form, this y equals mx plus b, and then what we do is we take our slope, in this case 2/3, and we put that in the m location, and then we take this y-intercept number, whatever the y-coordinate is, and we put that in for b. Remember, the x of your y-intercept is always going to be 0, so the b is really standing in for what is the y-coordinate of that y-intercept. That's what it's telling you, okay? So in this case, if I want to write this in y equals mx plus b, I would write y equals 2/3 x plus 6. Same thing down here. I also can do it the opposite direction, where in this case, I'm given a y equals mx plus b equation, a slope-intercept form, and I need to say what's the slope and what is the y-intercept. So I take that information, I can see in that location where the m would be is a 3, and I put that in here. And then I look over here and say, okay, there's a -7, so the -7 is going to be a -7 in where that b is, and so my y-intercept is going to be 0, comma, -7. I want to make sure that when I'm writing out my y-intercept, I write it as a point and include that x equals 0, the x-coordinate component to it, all right? So remember that b is the y-coordinate of your y-intercept. We kind of shorthand that a lot of times to y-intercept, but it's really just standing in for what's that y value going to be, all right? So here's what I want you all to try for me. So I have 3 equations right here, 1, 2, and 3. I want you to take these 3 equations. I want you to turn them so that they look like y equals mx plus b. And then I want you to tell me what the slope is and what the y-intercept is, all right? So I want you to rewrite these equations so they look like y equals mx plus b. And then I want you to go ahead and tell me what is the slope and what is the y-intercept, all right? Go ahead and pause the video, turn them into this form, write down your slope and y-intercept, and then come back and check with me. All right, so here we go, ladies and gentlemen. Here is my answers and my work here. So here's my y equals mx plus b equations. Now you'll notice with my first one, so here I added 3y to both sides, I subtracted 12, and then I went ahead and I divided by 3. And if you notice, I ended up with 2/3 x minus 4 equals y. And you might say, Mr. Guy, your y is on the wrong side. It's not y equals mx plus b. The y can be on either side, okay? What we're really looking for is that we have something times x and then plus or minus a number, okay? So a number times x plus or minus a number. And that's what we have on this side, 2/3 times x and then minus 4, and that's going to equal y. For this one, 2/3 is my slope, and then -4 is the y-coordinate of my y-intercept, so 0, -4 is my y-intercept. Up here for this one, I went ahead and distributed this 3 through, and then I divided everything by 2, and I got y equals 3x minus 6. The slope is going to be 3. That's the number with x. That's in the m spot. And the y-intercept is 0, comma, -6. Last but not least, we have y equals 3, and this one, kind of a trick question. I might have messed with you guys a little bit. It's already in slope-intercept form. It's actually already in y equals mx plus b. Now, you might say, but Mr. Guy, there's no x. Where's my x? In fact, you might have fast-forwarded because you're like, I don't know what to do with this. There's no x. Technically, that means there's secretly a 0 hiding with that x. Anything times 0 disappears, right? It equals 0. So this y equals 3, I can rewrite as y equals 0x plus 3 to really drive home the point that this sort of line will have a slope of 0, and then my y-intercept is 0, 3, because that's what's in that b spot. All right, so we got all our equations, we got our slopes and our y-intercepts. Now what we're going to do is we're going to talk about how do I go ahead and how do I graph these equations, how do I take them and how do I graph them. So when I go to graph something in slope-intercept form, what I'm going to use is the method of graphing the y-intercept and then using the slope to get my other points. So how does that work? Well, what we do is after we write down our slope and y-intercept, we're going to go ahead and take our y-intercept and we're going to plot that point. So in this case, I have 0, -4. So 0, I'm going to go down 4, and I'm going to put a point right there. Okay, so there's my first point right there at 0, -4. Then I'm going to take my slope, in this case 2/3, and I'm going to use that to plot out my other points by thinking of it as its rise over its run. The rise, how far up and down do we go? The run, how far to the right do we go? Okay? We're always going to start by trying to go to the right, and then we'll go to the left if we need to, because if we go to the left, we have to do the opposite of a rise. Okay? In this case, my rise is 2, my run is 3, meaning from this point, I'm going to go up 2 to the right 3, and then I'm going to put a point right there. Okay? Then I'm going to do it again. Up 2, right 3, I'll put a point right there. Okay? And then up 2, right 3, put a point right there. I can keep going as much as I want. I could keep going. If this kept going out, I could just keep going. And then once I have, we want like 3 to 4 points, okay? Once you have 3 to 4 points, I can go ahead and I connect these with a line. So I get a ruler out if I have a piece of paper. I go ahead and I draw my line out. I'm going to apologize right now on here, the way this line is going to be. Yeah, not perfect, okay? But obviously if you had a piece of paper, it could be a little bit better. Okay, but the line would go through all your points, and we would be able to see a good representation of what this line looks like by plotting that y-intercept and then using the rise and run to get the other points. Okay, same thing here. We're going to go 0, down 6, 1, 2, 3, 4, 5, 6. And then our slope, now if you remember when we got the slope, I said the slope was 3, okay? But I wrote 3 over 1 here. And you might be saying, well, Mr. Guy, why did you write it that way? That's because I wanted to spell out what the rise over the run is. Anytime you have an integer or a whole number or something that's not being written as a fraction, we actually think of it as being over 1 when we go ahead and graph it. That's the run that we're dealing with, okay? So for this one right here, what I'm going to do is I'm going to say, all right, we're going to go up 3, we're going to go to the right 1, and that's going to be my point. And then I'll do it again. Up 3, right 1, there's my point. And then up 3, right 1, there's my point. And I can keep doing that again as much as I want. We were looking for at least 3 to 4 points, and then we can go ahead and draw our line. All right. Last but not least, over here, we have a slope of 0 and a y-intercept of 0, 3. We're going to start by plotting that y-intercept right here at 3. And then a slope of 0, well, what's the rise and what's the run? Well, the rise, if we have a slope of 0, it's telling us that the rise is 0. It doesn't go up and down as we go to the right. So if I go right, I can go over any amount. Let's say go over 2. It's only going to go not up and down at all. Not up and down at all. Not up and down at all. In fact, what you're going to realize is that when you have a y equals mx plus b where the x has disappeared, the m value is 0, it actually means that you're going to end up with a horizontal line. Okay? And that's how we graph using y equals mx plus b or using slope-intercept form. We start with a y-intercept, we plot that point, then we use our slope to get the other points. All right? And that's going to be it for slope-intercept form for right now. So just the big things to take care of. Y equals mx plus b. That's our slope-intercept form. That m stands for the slope. The b stands for the y-intercept. If you know what those are, you can write an equation in y equals mx plus b. If you're given an equation in that form, you can pull out that slope and y-intercept because you know numbers that show up in those places, what they mean now, right? The m is that slope. The b is that y-intercept.